You know, if we wait 7 more minutes, this will be on time.
You should be able to.
All right, Michael, we're live.
Yeah. Hey, hi everyone. This is going to be super informal, so feel free to make this a conversation. Interject, I don't care. You might as well have some fun with this. So, I had originally made this talk kind of technical, and then I decided it might be inaccessible for some people and kind of, I didn't want to gatekeep the material and the topic. I wanted everyone to get something out of this. So I was sort of thinking about the topic that's on everyone I know's mind. You guys, at least I know some people here, are thinking the same way. Things are changing really, really quickly right now. We are literally in the midst of a Kuhnian paradigm shift. It's a rare thing to live through. Everyone's feeling overwhelmed, and what the hell do we do about it? And a talk like this, usually I'd want to go into some of the morality and ethics and discuss some of the deeper issues with AI, but that's not what this is about. This is an engineering talk, and the question is simply what to do now. And I'm happy to talk about the deeper issues because I'm very interested in them. But that's not what this talk is going to be focused on. And it's not all, there'll be some PowerPoint and some demos and crap like that. Anyway, so this is what everybody's worried about. AI is coming, AI is here. The first dire warning paper for AI was written in 2017, I mean first modern one with deep learning. That got republished in 2019 in MIT's Sloan Business Journal, which warned everyone that everything was about to hit the fan. And at the time, it really wasn't that plausible to be using LLMs. Certainly didn't seem that way. But this is what lots of us are worried about. Doesn't matter what level you are in the field, from a practitioner to a theoretician, everybody is worried about this problem. And part of the reason is the number of publications coming out right now is overwhelming. So if you've heard of Archive, which is the main repository for physics, math, and computer science, I'm a moderator for Archive for machine learning. These are just archive papers that I looked at in the past 2 weeks, and then some news things I clipped out. And this is really more than any human being can read unless you're super dedicated to keeping up with this. So the notion of a flood of information is insane right now. Pizza.
Good information.
What?
Good information.
That would be the most important thing I say to them. So the information coming out right now is very hyped. A lot of it is frightening. Yeah, it's frightening on many levels, and it's impossible to keep up with. So if you actually look right now at software engineering papers on Archive, 70% of them are about agentic coding, LLM-based coding. If this trend continues, in a little over a year, it'll be 100%. Of course, it's never going to reach 100%. There'll always be somebody kicking it old school. But you get the idea. This is really taking over. Keeping up with it, it takes all the time you possibly have, and then how do you do anything else? There's a sense of ignored at your own peril. No one's willing to do that, whether they're computer scientists or they're in business, or lots of fields that deal with information, from law to accounting. Everybody's worried that they're missing out. And I was trying to get some statistics. So in 2024, when AIs were really pretty bad, I mean, they were certainly not anywhere near where they are right now, 10% of all research conducted in the United States used LLMs not to help them write. They just used LLMs in their analysis to they cited some LLM as part of what they were doing. Now, we're not sure what the estimates are. People think it's at least 25%, and that's only going up. And if you look at archives papers, the percentage of papers, and I don't mean people writing it, like having it write for them and like cheating the writing, but actually using it in their research is estimated to be between 40 to 70%. So LLMs are spreading like wildfire, and they're a useful tool. I'm certainly not going to take the position they're not because I like them. But this fear of missing out, I think, is just overwhelming for people. Everyone's afraid if I'm not on top of the next great development, I'm in trouble. And I will mention, I'll be a little snarky in this talk. If you look at this, so this is essentially what's been published on archive and news articles I happen to run into in the past 2 to 3 weeks. Of everything I've read, probably in the past month, there's only a single paper that was worth my time. That was the paper, you may or may not have seen it, a multi-token prediction, which is now about to come to Llama, and it'll come to all of the other models. So everyone probably has heard LLMs are next token predictors. They tell you what the next token is. It's close enough to the truth that it's pretty good. Multi-token predictors do exactly that. They predict multiple tokens at a time. You get a huge speed up from that. How much of a speed up do you get? Well, wildly complicated question to ask. And you'll get a bigger speed up on a Mac than you will on Linux or Windows, because these are generally targeted for local LLMs. But if your context window is too big, you lose it. So it's a really complicated question to answer. Open research question. What happens if Anthropic implements it and then they nerf their model? So they go from float 32 weights to bfloat 16 weights. We don't know. Nobody knows actually what would happen in that scenario. So there's a huge amount of news coming out all the time, every day, and almost none of it is important. In fact, there was a paper, not many people here, God knows who's watching, but I doubt too many. There's a paper on midsection alignment that came out from Meta a week or two ago. Got a lot of hype. This is a nothing burger. It was obvious. You just had to read the abstract to know what they did. And it's fine, it's an optimization. But that it got so much attention and got people worried, it seemed kind of silly. Okay. And if you look at where we are now, this is one of the famous sites for all of the tools that, say, a business person might want to use. And there are lots of things here, and I'm sure you've all been there before. And GitHub, of course, has no shortage. It's probably the most famous repository on GitHub for Claude code skills. And there are literally thousands of these on GitHub. And what's actually kind of interesting is the overlap is extraordinary. Like if anyone ever publishes another RAG paper, I may go crazy because they're all the same. I don't know that there's been a new RAG paper in a very long time. And I know that's a bit hyperbolic and overstatement. But the amount of stuff that's getting repeated, because so much stuff is getting, and this is even at top tier conferences, it's getting a little bit ridiculous. So, and then there's kind of this constant churning, and I'm affected by this. I assume if you're into this, then this stuff crosses your mind. Well, I mean, there's this kind of silly question, what's the best model? And that changes, that can change by the hour, it depends what's being nerfed at the moment. But you always wonder, what's the best interface, CLI, or SAS? What changed this week? Has there been some new development, like have they doubled the speed of Llama? Now that's a reasonable thing to use on my machine for coding. Did something just change right now? Reddit's filled with threads that GPT was just nerfed. All of a sudden it can't do basic things anymore that it was doing an hour ago. And then the fourth one is the one that sort of drives me crazy. People are constantly reporting these amazing results. I have never seen one, and I have seen a lot of vibe-coded apps. I have never personally one of you could have done it, and I just haven't seen it. I've never seen a maintainable, well-written, conceptually clearly designed vibe-coded app. Maybe I will see one in 10 years or 20 years, but at the moment, no. What vibe-coded apps are to me are a wonderful way to prototype things really quickly, get something running really fast, take a look at it, and then you go write it in a real way. Because what you end up with vibe coding will not be maintainable or scalable. Although, again, maybe there are people who can do that. But I've never done it, and I've never seen anyone do it. So this fourth one, people get really anxious about. I don't think it's real at all. Okay, so what this talk is about, so those are some of the issues that cross my mind sometimes because I love thinking about this stuff. What this talk's really about is adding deterministic control to stochastic actors. LLMs are stochastic actors. They're random. They do random things. Random and software do not play together well unless you're doing randomized algorithms, which is a very formal thing that we're not talking about. And I miss Bob. And Bob is the curmudgeonly computer scientist who, when I was young, would lecture me about how the world should be and how I should write software. And the point of this work is to put Bob back.
Bob is also very, he has strong opinions on things.
Do you want to give the reference?
That's for you.
No, that's for you.
Okay.
Bob is real.
Bob is real.
Okay.
And Bob, so who do you think Bob is referencing? It's a movie from the late 90s, early 2000s.
With two Bobs.
Yes. Bob and Bob.
Office Space, right? Okay, so anyway. So what I want to talk to you about are 4 tools. These are, I'll say it now and I'll say it at the end. I won't keep focusing on it, but they're deterministic tools built on top of LLMs. And they do things that otherwise I think would be difficult. So there are 4 of them, and they just all have crazy names because that makes it more fun. There's Duplo. Duplo is writing designs. Duplo is, now there are lots of AI systems to write plans. Plans are not designs. Designing a system is picking a database infrastructure and architecture given what you expect scalability needs to be a year from now. That's not planning. Planning is when are you going to code it, Monday or Tuesday. Design is a completely different process. There's McLoop. McLoop codes for you. McLoop codes while you're sleeping. McLoop codes nonstop. McLoop is always running. And I like McLoop because I'm lazy and I don't want to code all the time. I'd rather have someone else do it for me. There's Orchestra, which we're going to talk about. Orchestra is Bob arguing with himself. I'm sure you've seen publications addressing this, like the famous council model. 70% of papers in that field are all essentially repeats of previous ideas. Only so many new architectures people are coming up with. Vroom is the latest part of this. Vroom is design on the design. Vroom is, this is all a recursive process. Vroom is taking the thing you built, taking your spec that Duplo built, saying what's missing here? What didn't we add that should have been here? Let's do it all over again. So the number of times McLoop has rewritten McLoop. I wrote the first McLoop because it didn't exist. Now McLoop rewrites McLoop. I don't code McLoop anymore. I direct it, I give it feedback, but it writes itself. So these are the parts. And I sort of already gave you this. Bob was your classic computer scientist of what are you doing and why.
To the east of Moldova.
Sorry, I was trying to check the stream, make sure we went.
So, are we in Moldova?
No.
So, 2 points about Bob. I'm just guessing that most people here who are into computer science don't look like they graduated yesterday or this weekend from undergrad. You probably had a more classical, like I did, exposure to learning computer science, where you were told things like slow down, write specifications, make contracts between parts of your code. It was annoying, but it worked, and it actually worked really well. And I'm going to argue we don't do that anymore. Okay, so before LLMs exist, we did spec reviews, we did design reviews. In fact, the rule of thumb was to spend, before you did any coding at all, and of course these are rules of thumb, no one really did this, but you spent 2/3 of your time designing the software, 1/3 of your time coding it. That is the universal rule in computer science, probably since the 60s. Does that mean while you're coding it, you don't go back and revise your design? No. Because just like a battle plan, no design survives your first encounter with your compiler. You always have to go back and change your design. But that doesn't mean you don't spend a lot of time on the design in the beginning. So we did spec review, code review, deploy review, then we did, after it was released, what came back that, not just to fix bugs, but why did we miss them? Which is a really deep thing to wonder about. How did you miss the bug in the first place? Vibe coding. And I'm going to be a little glib about this. Vibe coding is sitting down and sort of, and there are people who do it properly, and I know there are. But it's very much saying, I want this. I mean, if you watch some of the demos or the videos that come out of the large AI companies, build me something that, I've seen some of the painful videos, I've seen the demos of web apps, and there's no discussion of infrastructure or computational needs or scalability or security or access models or denial of service or sharing it with other people or moving to other accounts or even accounts. It's basically putting up a really messy prototype that barely works, and there is no design. There's certainly no review. There isn't an audit, because what would they audit with? And the loop is essentially one model deep. You run it, you tell it what you want in English, you build something, you run it, it does something. Maybe it's what you want, maybe it's not what you want. And then maybe you try and talk with it and get it to change. But that is a very, very awkward way to code. I know it's great to say, build me a game with a cat in English. But to actually get what you want is an extraordinarily difficult task. And there's lots of theory behind this. I mean, like real theory, like Kolmogorov complexity. The shortest description of any program is the program itself. You're not going to get what you want by writing in English, if you're particular about what you want. So what I want is an agent that's fast, can do something fast for me, like I forgot SQL syntax, which I do all the time, and it can write that for me, great. But so it's fast when it can be, it's slow when it needs to be, like fixing bugs and auditing things. And it does the stuff that I was taught to do when I learned how to program, design, build, review, and audit. But I want it to be doing it by itself. I want to automate it, because I want to go to sleep, or I want to go do something else. Okay, so I'm going to talk to you about the 4 components, and I'll give you a demo of Duplo. So all of this runs in, I won't say real time, like Duplo is probably going to take 15 or 20 minutes to finish, so I'll start it now, and then you'll get to see what it does. The idea with Duplo, it came, the first thing I did was McLoop. The idea with Duplo was this. And it started with just apps on the web, like that you could download or buy. Most of them have manuals available. They have screenshots. It's very common to have movies now of people interacting with them where you can watch the screen. And what I wanted to do is just give the URL. The first version of Duplo just took a product URL, and it duplicated it for me. First thing I ever duplicated was Super Whisper, because I didn't want to pay $120 to license it for a year, because why? Why would I? Because didn't do anything. It's easy enough to build myself. So that was the idea of Duplo. You just give it a design, and we'll talk about how that's written, or you just give it a URL, and it goes out and duplicates something for you, which McLoop will then build. And so this is the idea, the design is the most important thing in computer science. Well-designed code. You can use, this also is interesting, you can use a lesser coding agent if your design is well-spec'd. If your design is opaque and really hard to understand, or needs some great decision to be made, or some algorithm written, no. But if your design is very clear and easy to follow, you don't necessarily need to be paying for Opus and spending huge amounts of money on tokens. So, okay, I think most of this goes without saying. So, the current version of Duplo, you can give it anything you want. You can give it a URL, you can give it images, screenshots. It can be screenshots of other apps that you want this app to look like, doesn't matter. You can give it videos, it will watch the videos, it will look at the eigenvectors of changes between frames to find scene changes to see when something new happens, and it will pull out everything.
Music?
From,
Are you trying music as well?
no, and I was reading my mind this
That's
afternoon
okay.
because I had a video where they were using that, and it didn't work. So no, I had not done music, but I'd like to. I don't know enough about music. You can give it PDFs. Grab your 5 favorite PDFs of features you want. Just give it to it, and you can just write prose. This is what I want the app to do. Okay. So this is an example. There's an app called the Numi app, which is my test bed. Yeah.
I was just gonna say one thing. I just wanted to comment. When you just said about, like, I'd like to do music, but I don't know enough about music. Like, just to me, that stuck as a, like, that's legit. That's someone that knows how to actually code something, you know, with AI tools and everything, right? If you don't understand the subject, like everybody else thinks you could just, anybody can build anything. But you have to have some good knowledge behind it, or it really helps. So it was like
Yeah.
the way you responded to that.
I happen to think formal
resonated.
computer science education is absolutely crucial. Today, maybe more than it ever has been, but I know many people don't think that. So this is, there's a thing called the Numi app. It's actually the source for it. He sells it, but he also, with some extra features, it's essentially like a text calculator. I can show you, this is my version. Let me just make sure I'm showing you my version. Yeah, it's mine. And it's clear. Oh, well, you can do things like to, what is this version? This is not the version. Oh, here's the version. Okay. So this I just pointed, oh, you can't see it, I'm sorry. Okay, so this is just a text calculator that you can do random things with conversions. It updates and gets conversion rates. This is, I point Duplo at his website. I used to run this every single night. It's my integration test. It checks every part of Duplo and McLoop, from watching pictures to watching movies to coding it. And I just used to run this every night. Now I'm looking for something new to run every night. And he gives it away for free. You can buy it if you want cloud features, which I don't care about. But since he gives it away for free, I don't mind using it as a demonstration of duplicating someone else's software. But it's some of it's kind of silly. I don't even remember how to reply. I don't know. I don't even remember the syntax because I don't even use the thing. I just use it as a test bed, and then I run through all the examples in his documentation to make sure it works. Okay, so the point with this is, is there a laser pointer anywhere?
you have?
Well, the top Duplo line, this is how it used to work, Duplo in it, and a URL, and it would just go off and scrape the website. It would get the documentation, every media file it could, and then you just run Duplo, and it would extract features, and it would generate a build plan for it, and you'd call McLoop, and McLoop would build it. And we'll talk about some of the other features here. Duplo fix, labeled expressions don't evaluate. Some things weren't working. So there was a way to, this is now a little bit more sophisticated. And we'll talk about that. McLoop wraps things and automatically fixes bugs.
Quick question, does it read like the open API spec kind of thing and then look at the endpoints and then copy it from that way, or just visually?
Open API spec for what?
For if it's an API, if it's an app. Or you're looking at the web version.
Yeah, I was just going.
Okay.
I was just going on the web. This actually, OpenAI was no OpenAI electrons were harmed in the making of this app, so this was not built with OpenAI. So anyway, this was the whole thing, and here's some of its behavior. It was just a trivial thing to build. And what Duplo generates, if you ask what it's actually coming up with, it's coming up with plan files. And I'll show you. Why not? I'll show you McLoop's plan file because it's kind of big because it keeps adding to it. And something that's not checked off is open, so there's a bug that we just saw that was reported. And then there were tasks. This was somewhere in the building of tasks that needed to be done. Talk about what these mean. There's various information recorded in the plan. And let me just very quickly show you the plan for so this is McLoop's plan file, and this was the core. This was after I got it running. This was the very first thing I did to add basic functionality to it, and we can just keep going through it. These are all things that were automatically done by McLoop, building McLoop. And every time it reaches a new phase, it stops and loads the new phase and then continues. So as it gets more sophisticated, it keeps getting more sophisticated. And this goes and goes and goes and goes and goes. And and there's a feature, if I manually edit something, to go look at what I did, look at the Git differences, and then add it to this where it belongs. But this keeps up to date, so you can take this and you can give it to McLoop if you get rid of all the check marks in the tasks, and it will go ahead and build itself. It may be a different version of itself, because again, it's stochastic, but hopefully it will be a running version of itself. So anyway, that's a very long plan file.
So the underlying LLM is what? What are you using for the underlying LLM?
We'll get to that.
Okay.
Okay, so the main thing that one of the reasons I did McLoop is exactly this. It restores the incentive to design carefully. Yes, you can point it at a website and build an app. Much of the time I just use it manually because it actually makes you stop and think about how to design things, how to organize builds, which is not something that's easy to do if you're vibe coding. And this is a habit that computer science has been losing wildly. This is one I would be worried about for the future of computer science, not knowing how. When you ever met someone who's written an operating system for a nuclear reactor, I don't know if you have, those are one of the most sophisticated software entities in existence. They had damn well better know how to design an operating system. They're not going to learn it by vibe coding. although that's an extreme example. So McLoop. You changed the order of the slides. Yes, I did. Okay. Before we do McLoop, we're going to do Orchestra, because Orchestra will answer some questions that were asked, and we can't go into McLoop yet until we talk about Orchestra. So this is Grumpy Bob, our curmudgeonly computer scientist, fighting LLM slop. Different models, different jobs. And the idea is to have them interact with each other, and not just have them interact with each other, but to learn what their strengths and weaknesses are. So if somebody asks me today what's the best model for coding, well, I have my opinion today of what the best model happens to be, but when the new release comes out tomorrow of something, I don't know a thing about it, I have something to automatically test them and evaluate them for me, for my workflows, because the benchmarks are not useful. I'm not going to say they're dishonest, I'm just going to say they're not representative of real world performance. So, I think we've all seen this. The best LLMs in the world, ones that are not even available to the general public, that are only for internal use at some of the biggest companies, they will fail spectacularly. And I've seen some whoppers that are really hard to believe. And there's no exception to this. So the idea of coming up with some kind of architecture, it's not optimizing. It's the only way you're going to get these things, given current technology, to work. Maybe 10 years from now it'll be different. But right now, this is the only way I know. If you have an idea, tell me. I'd love to know. So I'm going to go through these. We don't need to read through these now. So this is the simple model you're all familiar with. You've all done this. You have a question. You have something that's going to answer it. It could be, if you're sitting at a desktop, it could be ChatGPT. If you're writing a program, it could be GPT through its API. Or it could be, you could be connecting to Open Router and connecting to whatever model you happen to want to use. Or you could be connecting to DeepSeek on Moonshot. Whatever you're using, it's fine. So this is the standard model that we're all familiar with. Okay. Here's another model. Here's my input. I'm going to get some kind of draft answer, and then I'm going to take my input and the first pass at an answer, and I'm going to feed it to another model. Same model, different model? I don't know. Does it turn out that, do these both need to be Opus? No, that's expensive and wasteful. It turns out combining weaker models sometimes gives you pretty good performance. In fact, better performance than you might get from an expensive model. We'll talk a little about that. So you can have your input, send it to several models, why not? So you have your question, send it to a bunch of LLMs, and then you have something that reconciles, that puts them all together. And my partner Tina asked me, isn't this perplexity? And the answer is no, because these are not websites that you're sending a query to. These are LLMs that are processing a single input, and they're all analyzing it and then being reconciled by whatever it is you pick to do it. And in general, what I suggest is the guy at the end is the most powerful. These matter less. The one at the end may be worth using that one for. So this is a different model. This is a model that I happen to love for coding. This is my favorite coding model of all. Your input, get an answer, get somebody to tear the answer apart, and then get somebody to say, like a referee, cut it out, guys, no fighting, let me figure out what's going on here, and I'll tell you what the answer is. This is a good, for me, this is a good coding model. This works. And what's really neat is I can start using models that are 2 orders of magnitude cheaper than Opus to get this done. 3 orders of magnitude cheaper.
Which one of those is your bigger one, your better one?
Better.
Which one of those 3 positions would you put your best quality model?
The one at the end always.
Got it.
Although maybe I'm wrong. I mean, I'm running permutation experiments on all of these, but it takes a long time. Okay. The anonymous reviewer model. This one's kind of fun. Get your question, feed it to, these could all be the same model, different prompts, different model, different prompts, same prompts, whatever. Anonymize them and have them review each other's outputs and come up with an answer. This is an interesting model. And this is probably the most infamous of them all. This is the council, which I'm sure you've all heard of this. Anthropic has made a big deal about this model. You have your input, you send it to the contrarian. It's going to be critical and nasty. You send it to the first principle guy. He's the nerd who's just going to reason about it. It's kind of the way I would reason about it. Just what's the answer to the question? The expansionist is, oh, let's think of something more grandiose. The outsider, I'm not even in this field. Let me tell you what my intuition is from another perspective. And the executor, not executor, the executor is, what could I do right now? I want to get busy. I don't want to sit here. What's actually possible right at the moment? And then the chairman puts them all together. And one of the things with Orchestra, because it's at least hard for me to get intuitions about lots of things, is all of the libraries, you can just I don't know, somebody give me a question.
Yeah, on the anonymizer model.
Well, give me a question while this runs, because this is going to take like
Who's the
30
president
seconds.
of Canada?
I'm sorry.
What?
I thought you wanted a
Who's the
question.
president of Canada?
That won't have any controversy.
How
Who's
does they
the
answer?
president of the United States?
There is no president in Canada. It's a prime minister, right?
Should
I think he's looking for something where they argue it. Well, I don't know, that'd be an argument, you'd think.
Yeah. Right.
Somebody might.
It's not an argument, it's a contradiction.
So I just called Orchestra, so all of these things
Excuse me,
are
and the-
libraries, but you can just call them directly. And I don't know why. Okay, so we call the contrarian, the first principles, the expansionist, the outsider, and the executor. It's calling them all in parallel, getting their answers, waiting for them to come in. Should take like 12 seconds or so. And here they start coming in, and then it will assemble them into a much more thoughtful answer than I'm used to getting from an LLM, because it's presenting all perspectives, and you can have more perspectives. Yeah.
On the anonymizer model, are those, you had providers, 5 providers in a row, and then you had 5 analysts. Are those the same software
It's up to
again?
you. There's a meta language to describe any infrastructure or architecture you want, you can write. There's a meta language to describe it, to connect them to models, to link them together, to feed them, to write prompts. There are whole libraries of these things. So this was its answer, and we'd have to kind of so 4 of the 5 advisors converged independently on the same thing. You not named delete all AIs is a mood. All right, fair enough. Which is somebody spouting off, let's delete all AIs. It was a very concrete proposal. I'm curious who the real disagreement between the expansionists. These kinds of answers are actually interesting to read. Whether they're useful programmatically, I couldn't tell you. Are they interesting? Yeah, because the perspectives are ones you don't normally see from an LLM, at least in my experience. Much more thoughtful. And they're much less likely to commit to a particular perspective rather than give you various views you might want to consider. So anyway, this is the Orchestra library, and I'll make
Never
the
at
point,
11, yeah.
making your library interactive this way. It also has a CLI, if you just run Orchestra and give it a command that you can interact with it, is really, really helpful for getting intuitions and playing with it. Because if you're only playing with it like it's in some buried code loop 40 layers away from you, and you can't touch it and see how little changes to the prompt affect what it's doing, I can't understand it. So only using it like this do I get a sense of what these models are doing, and it's why I love that multi 3-layered one for coding, because it works so nicely. Yeah, is there a question?
This is an impressive amount of work. How long did it take you to do this?
This is over 1 million lines of code, and it's taken me many months. So, yeah, it's a lot of code. But thank you for noticing that. Okay. Okay. So, and I just showed you just dealing with the orchestra, putting the model you want, and putting in a question. Really nice way to get some intuitions about these things. So the question was asked, what model am I using? Well, right now I'm primarily using 4 models. How many models could I theoretically use? Probably 27. And I have another program that Chris has seen that uses 73 models. But that, you gotta be a little touched to play with that one. But these are the 4 leading models in the world as of yesterday morning. As of yesterday afternoon, Ernie was released by Baidu, and Ernie is somewhere here. Where it is, I don't know.
You're not running DeepSeek V4 locally, are you?
No.
Well, I'm able to get the step down now in mine, but I gotta.
No, I'm running on an open. I think I'm running on an open router now. It's incredibly slow, and I need to find a new host for it.
So is that the same V4 as what they released end of April?
Yep.
That is now open source.
This is the V4 Pro. This is their top model.
Okay.
What's interesting here is one of the things, since I'm generating a lot of code, even if it's repetitive, I don't really care, because I'm like saying that every night, is, boy, I'm sorry, I'm going too long.
You're good, you're good.
Oh, and I forgot to start my damn demo. Oh, hold on. I haven't started because you got to see it, and it's kind of cool. And
Do you want to take a moment to do that, and we just grab pizza?
Yeah, grab pizza.
All right, guys, if you want to grab some pizza here.
Unless you want to, and you can watch how I start the demo.
Information stack.
Go ahead.
Okay, so I made a new directory. I told Duplo, I want you to duplicate Super Whisper. So this is the thing everybody uses to talk to their LLMs. And
Is there a reason why it did it in Swift?
pardon?
Is there a reason why it did it in Swift?
Because I'm running a Mac.
Package Swift. Was Swift a choice that you made, or the model system made?
I made it. So this is first going to go off and get basic information, and then I'm actually going to tell it to do it in Swift. That was the old version I ran this morning to make sure it would run as a demo for everyone today.
But they changed something since then, so it probably won't work now.
Machine cutting the line and reducing all the.
I said small pizza, no big pizza.
You're good, you're doing well.
So this is for the guy who asked why it's going in Swift. The only thing I'm specifying, I gave it the URL for Super Whisper. It went and took a look at the site to get some idea of what it is. I tell it my platform is Mac OS, built in Swift, use the Swift package manager, use the same version of Swift, which it would do anyway, because for all the platforms it uses, it builds a database of reasonable defaults, and no external dependencies. So there's really nothing surprising about any of this. I do that, and then I just run Duplo again. And this will print out, we'll look back at this. This is going to take a few minutes to run. But you'll see it reporting on all the movies, all the files, all the images, what it learns from them, watching it. I wanted this to be an exact duplication, so it pulls out the fonts, it pulls out the sizes, it does a great deal of reasoning, it gets all the documentation, searches for everything it can in order to actually end up building this. So, and so it's scraping one source at a deep depth, and it's going to come up with all the features, cluster them, and figure out what needs to come first, what the build order is. That's real design. That's not planning. And it will ask us which features we want. I don't want the enterprise features for this product, so I'm not even going to bother building them. There's no purpose to it. So we'll let this run, and we can look at it afterwards and go back. So one of the things I've been doing is collecting huge amounts of data. I'm not exactly sure what I'm going to do with it, but this is great data to get. I love getting this data. It's rare that you edit millions of lines of code, which of course leads to lots of bugs, and you can just collect everything. Like, what did I miss that I should have caught and why? That's the thing I wonder the most about. When there's a bug, how did I miss it? Why was it missed? Sometimes it's my fault, sometimes it's just missed. And sometimes there's a bug in an underlying tool. So what's interesting here is, look at so this is during auditing. One of the things, so this isn't, there was a bug, let's fix it. This is we're constantly auditing our code base, even if we think it's fine. And this is over different code bases and lots of programs. So the exact numbers don't really, it's really the ratios of them. So Kimmy had the most number of unique finds of bugs, of any of them. None of them found false positives. OpenAI did find false positives and then said, nope, it's a false positive for every single one, which I thought was pretty cool. DeepSeek found bugs that everyone else found. Never found anything on its own. So of course, why include it? Just drop it, because it does cost some money, it does use up resources, there's no purpose to it. If I was only going to debug with two, it would be Kimmy and Opus, easily. The most stable of them all is GPT, and we can talk about what that means. It's the most predictable and stable by far. And if you look, this was just one example of a debugging session, of an auditing session of the four, how they ranked bugs and if they found the same bugs. So Kimmy, Claude and Codex found it. Kimmy said the bug's critical. The other one said. I guess part of this, the reason I do auditing is to find mistakes before code crashes, because static audits are incredibly useful, and the code writes unit tests, heat tests, acid tests, integration tests. It writes all these by itself for all of the levels, and it's constantly running them. So a reasonable amount of its time. If it does this too long, I don't run it as often, because some of the tests can be resolved. But the point of this is to catch mistakes and fix them, but there are a bunch of other things McLoop does that I really, really love. One of the things is every app it builds, and you can connect it to an app it wasn't built with, builds what I call self-healing apps. It adds infrastructure to every app, so if that app happens to crash, it records everything about that crash it possibly can. Will it record a core dump? If it can, it would. Does it record everything about what was going on? The stack trace, yes. And the reason for that is then it will do an automatic bug audit. If an app crashes, we'll say, it will come to you, and we'll even send you, I think I have a phone message example, we'll send you a message on your phone, I crashed, do you want to debug me? Or do you want me to be debugged? Yeah, go ahead. That's an investigation mode. You have something you wrote that's not supposed to tell you the weather in Detroit, and it's telling you the weather in Florida. You can say, McLoop, investigate, why are you telling me the weather in the wrong city? And it will go off and do that. It does continuous code review, nonstop. This is always going on. It's always checking itself. And you might wonder, doesn't that always lead to it finding mistakes? It could, but it doesn't. It's like if you edit a paper and you keep asking ChatGPT, is there a mistake in this paper? It'll keep finding mistakes. I was actually telling Chris, when I was doing this, there's a famous algorithm book, the CLR, McCormick, Leaderson, Revest algorithm book. It's like the Bible of algorithms. Those guys are gods. I gave it algorithms from that book, and both Opus and GPT were finding errors in them. And that was useful, because those were like ground truth. There are no errors in these algorithms. If your claim is a mistake in an algorithm Charles Leaderson wrote, that's been through 20 editions of the most famous textbook in the field, no. So that's part of how I got this to stop. There's a maintain mode where you can say invariants you always want to be maintained. Interrupt and resume, you can kill it at any time, Control-C it. It will save everything about its state so you can resume it, which that was just something I wanted because so few programs have that ability. Like when we got in the car to come here, close my laptop, kill it, get in the car, open my laptop. I just wanted to go back to what it was doing. Not putting it to sleep, killing it, and having it resume. And other stuff that's really cool. So Vroom is the last part of this. So Vroom is the thing that it's a daemon process that's always running, and its goal is to find things. Will it find things to fix? Yes, but that's really not its point. What its goal is to find bugs in your specification, your design. Not that your design is bad necessarily, but maybe you didn't think to add something that is suggested by other things that exist. Maybe there's a feature that didn't occur to you to add, or didn't occur to me to add. Like with McLoop, I kept coming across, why didn't I think to add this? And then I go and add it. I wanted to automate that because I didn't want to do it myself. That's exactly what this does. So they review the code. They all came up with some number of findings on the top. And then we said that 4 of them were reasonable to consider, and there are really only 3 unique ones. And then we start modifying the file that McLoop would generate, not McLoop, the Duplo would generate to feed to McLoop to actually implement those new features or changes. So silly, it's like the singularity moment for me. It's when the software starts improving itself without my having anything to do with it. Is it perfect? No. Does it always work? No. Does it sometimes work? Yeah. Do I like when it works? Yeah.
What happens when it doesn't work? Do you get angry?
It kicks them out of the house.
I've been known to be rather abusive to my. That's not good.
We won't go there.
Okay. So I said, where does this come from? Because at the beginning, and I know Chris did exactly the same thing. I had Claude open, I had GPT open, I had OpenCLI open, I had desktop for Claude. I had all of these, and I was cutting and pasting between them because they were all making mistakes, just constant mistakes. I couldn't get them. There's this principle of fixed point, idempotency. I give you the code base, is there a bug? Tell me no. It would never tell me no. It just keep finding something wrong, even if it wasn't wrong. And I got tired of that. And then I wrote an MCP server to automate all of that communication, but that was kind of fragile and flaky. And what I wanted was, you can't fix this from the inside. You can't add a stochastic solution to a stochastic process and get a predictable output. You have to have something on the outside that's deterministic, that's checking everything, that's checking everything's formatted correctly, that's checking nothing. It's just so easy for any of these models to screw something up, and they do. If you run the way I do, of 24/7 and arrange your sleep schedule around when you can get access to these machines, if you're really using them intensely, their mistakes are obvious. People worrying about them taking over the world, I don't think they can take over my toaster. There's just so many mistakes.
It is analog. It's just a resistive wire.
Yeah.
Fun.
I have a bagel, I'd rather have a toaster.
Oh.
So what are some of the downsides? Using multiple models has multiple costs, so I pay for subscriptions both to Claude and to GPT. I've also just paid for tokens on occasion because I literally get to 99% of my usage. Everything is planned to hit 99%, so I'm not wasting a nickel on bastards. I'm not going to give them any of my money unless I'm using it. So I hit 99%, and then I wait an hour till it resets, and then I keep going. But the less expensive models, Kimi is cheap. Yeah? A kid could pay for Kimi, and Kimi's awesome. Many of these models are incredibly powerful, and if you connect them in the right way, maybe they're not as great as the latest Opus. Maybe they are. I don't have an answer to that. I don't think anyone has an answer to that yet. And what's interesting is there are many cases, and this is well known, and there's a lot of fighting that goes on about this. They are much more similar than people like to make out. Their prompts are really what often make them different. Particularly there was a period where Kimi, if you asked it what model it was telling you it was Opus. You can guess why. You can Google if you don't. If you know, you know. Whatever. Anyway, so Bob isn't free, but he's way cheaper than the alternative. I didn't mention that every iteration of a stochastic model is with a fresh context. There is no drift or hallucination cascades. Every model, I create the context from scratch. There is never a model called with a pre-existing context. No, in anything here. So the context is minimal, it's pruned, and it has as little in it that would lead to the kinds of things that we hate that mess everything up. So my goal is 1,000 useful commits a day. My record is 267. I almost came to my goal this weekend, but it didn't get to the main branch, so it didn't count yet. But the point here is, how do you get this code written quickly and usefully and not end up with junk? And that's all. Oh, and I'll show you, let's see if the design finished. If it didn't, I'll pretend it shouldn't have. Okay, so here it is. So I analyzed Whisper, the Super Whisper. It came up with 37 features that it thought were fundamental to it. It found, it pulled out 13 pictures from images on the site. It should talk about, it found videos. It took 12 videos, 12 frames from one video, 14 from another, and decided the other ones weren't interesting or important. And it pulls out really low-level details, every visual design aspect, because I wanted perfect duplication. It comes up with features, it then clusters them. Here are the core features. This is what you need to get a usable app. There's quite a few. Here are user interface tweaks. Here are integrations. Like as if you want to bring your own tokens. So you want to pay for your own OpenAI tokens for speech. There's security ones, which are, every enterprise is going to have some kind of security thing. And That's interesting. We put the free tier with other. Every time you do this, you'll get something different. And I would probably say, show you 137, and I want the free tier. It doesn't really matter because it's my app, so I can just get rid of the licensing altogether, but might as well.
What does it take, from an equipment perspective, to run this?
This takes nothing. I can run this on my phone. In fact, there is an app. One of the things you may not have seen it is the phone app version of this. And I have built phone apps.
That's why you did it.
So anyway, this will generate, so it has the design, this will now generate how to put this all together in order so you actually get something that works. And this will run, and if we're still here in 5 minutes, I'll start Duplo on it, not Duplo, I'll start McLoop on it and see it start building. And it will, if we come back tomorrow, I'll have a running Super Whisper. It's called McWhisper, because it's like McDonald's, it's all a commodity, bespoke software. And it'll be available tomorrow, because as much as I'd like it to finish in 15 minutes, it's not a reality with the speeds you get. So anyway, that's all. Thank you. Sorry I went over.
Legend!
Michael Cohen, everyone. And everyone here, thank you so much for coming to attend this event. I hope you guys learned something. I want to thank our sponsors, IEEE, for helping host this event and providing pizza. So please consider joining IEEE. We have a number of members here, so thank you for being members. If you're not, consider it. Also, thank you to everyone else that's here that has contributed in the past and is looking to learn some more. We're open to volunteers as well, so if you're interested in helping out, please see me afterwards. If you're interested in learning more about Michael's project, you can contact me or Michael. Michael's email was at the bottom here. I'll post his slide deck if that's all right with you. We'll talk about it. I'll get you his contact information if you just connect with me, and we'll get that information out. I do know that Michael is looking for some pilot users. So if anyone is looking to build some software and you might have some money lying around to help pay for some token builds, he would be interested as well. So
Pay for your own token.
yeah, exactly. And then last but not least, look for a QR code here shortly. That's just an after-event survey. So, all right. Thank you so much for coming. Help yourself to a slice of pizza, and then we are also planning on going out for a beer afterwards. So if you're wanting to stay, and we'll go to Paul's Club for a beer. So anyway, thank you so much, everyone.
Thanks for putting it together.
Taking questions? I wonder the impetus behind this. What is your goal in this work? Is this to make your life better, or to come up with a product that you can sell, or what's your goal?